Good evening, Katunja Brendan. We are Group 23. We are going to talk about our project titled Graph-Based Knowledge Distillation for Unsupervised East Coast Fever Detection. We are going to start with the introduction. Uh, East Coast fever is a fatal sickness affecting the cattle populations, Eastern, Central, and Southern Africa. The disease is transmitted by a tick, Rhipicephalus appendiculatus. It is caused by a protozoan, Diphtheria pavapava. Some of the symptoms of this disease in the cattle include swollen lymph nodes, difficulty in breathing, drop in milk, drop in meat production, loss in appetite, and also another cause is that the temperatures of this cow may increase. So you can see it causes some potential losses in the production of the farm, and also causes a potential loss of this cattle because it's dangerous and it may increase the mortality rate of this cattle. Early detection and accuracy, early and accurate detection is essential and very crucial for this disease management. That is why we have come up with this machine learning model. The nature of this disease is that if it is detected early, it can be treated and it may save the life of this cattle and also increase the production on the farm. And also, if it is detected very late, chances are high that this cattle may not survive, but it poses potential risks and losses the farmers. Some of the keywords used in our machine learning model, one of them is the East Coast fever. This is the disease that is caused by the protozoan, and it is transmitted by the tick called Rhipicephalus appendiculatus. Another keyword is the machine learning, which is a field of study in artificial intelligence that is concerned with the development and study of statistical algorithm that can learn from the data and then generalize unseen data and that perform that without explicit instructions. So we are going to train this model using our data set, and we shall be feeding it with some new data from the field so we can be able to detect the presence of this disease. And then another one is predictive modeling. It is a process of analytical and statistical techniques to analyze the past data and make predictions about the future behavior. And then the graphical networks, which is a class of deep learning methods designed to perform inference on data described in models. Knowledge distillation, a technique of transferring learnings from a larger model or a teacher model, a student model or a smaller model. And then supervised learning, which is the type of machine learning that learns from data without human supervision or without labels on the data set. Move on to the problem statement. As I earlier stated, this disease is usually in Eastern, Southern, and Central Africa. Specifically, in Uganda, the cattle keepers face the challenge of identifying a potential outbreak. This host fever is very, very essential for this disease management. So if it is detected early, it can be controlled and then save lives of these cattle and also increase the production of the farm. So however, we have this machine learning model. There are some technical computational problems that will come along with it. One of them is that the data used to train this model may not be consistent and accurate, which will affect the accuracy of detecting this disease. Another one is the imbalanced classes. We may collect data and we find that data we have collected, one of them is accurate and another one is not. One of them is positive and another is not negative, and we may find that more of it is negative, so it may pose potential bias during the functionality of this model. And then another one is knowledge distillation, and this is create lightweight model for deployment. Consistency of complex models without losing accuracy is difficult. So this distillation will involve making larger models smaller models, which will cause the accuracy of this data set very, very difficult, and also it will affect the performance of this model. And then unsupervised learning challenges arise when clustering cattle based on genetic resistance, as resistance levels are not always well defined. It may also cause a potential inaccuracies in the performance of this model.
Good evening. My name is Bainom Shadek, and I'll be continuing where my colleague has stopped. So, the proposed solution, I will be taking you through the proposed solution. So, we are planning to design a machine learning model which can come up with a better solution for detection of viscous fever. And the machine learning model we are planning to design will be providing real-time predictions, maybe like telling the farmer, like there is a high or low risk of viscous fever infestation of your farm, and it will also be providing actionable recommendations to the farmer, maybe telling the farmer that invite a veterinary doctor as early as possible, or you could also tell the farmer to also apply pesticide or acaricides or spray the animals as early as possible, and this will enable farmers to make important decisions that reduce the viscous fever risks. Especially, we found out that once viscous fever attacks the farm and it's not early detected, it will lead to the death of many animals, because these ticks that spread this that spread this that spread this disease, they're able to move from one cow to another. So the machine learning model we are planning to design will help farmers to make such important decisions. And the proposed machine learning model will be combining aspects of graph neural network and supervised learning and knowledge distribution, as my colleague had talked about. And the simple illustration we can have here, we have the perceived cases or registered cases of ECF under different seasons, and we know that the rainy season registered more cases than the dry season, which is an important factor based on the climatic season, showing that the rainy season will always register more ECF cases than the dry season. Next, I'll be taking you through the expected outcomes. Now, the expected outcomes of this solution are categorized into two. First, we are aiming at tackling the application specific problem by developing a highly accurate predictive machine learning model that can reliably assess the risk of viscous fever in cattle. Second, we are planning to address the technical and the computational problem by creating a mobile-friendly, lightweight machine learning model. And this model will be optimized using knowledge distillation, ensuring it performs efficiently even on devices with limited computational resources. Maybe a person has a phone with Android, which is a lower version compared to these latest ones. Next, I'll be talking about the dataset description. This dataset was based on the research of Thelaria Pava Pava protozoan, and this research included multiple samples with various features like genotype, environmental condition, and host characteristics. And basing on that, that is what they based on to make this dataset. The source is that you can copy it and you can copy it and access the dataset, and the size is that 86.8 KB. It is small. The features I can go through them briefly. We have the name, which is the unique ID for each cattle, the genotype, which is the genotype categorization, which includes 54 and 800, the ECF, where 1 indicates that the cattle is infected and 0 indicates the cattle is not infected. The farm and cell, this shows where the samples were collected from. The latitude and longitude, these are geographical locations of the cattle. X and Y EPSG, those are X and Y EPSG coordinates. Tick, this shows the tick infestation probability. The Cape buffalo is it is an animal that transmits these brown ticks, and once your farm is located near game parks or wildlife reserves, your farm is on high risk of being infected by the viscous fever or being attacked by these brown ticks which spread viscous fever. The cattle shows the cattle density. The biofile shows the maximum temperature of the warmest month. Next, I'll be taking you through the pre-processing steps, and we have two. First, we are going to be using data cleaning, which will involve removing any missing values where we have NA, and this this will involve using techniques like imputation or removing incomplete samples depending on the extent of the missing data. And next we are going to be using feature engineering, and this will involve normalizing geographic coordinates. So in our data set you have the longitude and latitude, so we shall normalize them so that they to ensure they are on a consistent scale to enable the machine learning model to learn them faster and much better. And next we are going these are references we use. The first one is based on the data set, and the next one, the other ones, are the ones we use to address to make research on the data we use to make this research. Thank you.